Hello everyone, welcome to the next lecture of electronic devices. We are covering chapter number 4 on diodes, and this is lecture number 2. In the last lecture we talked about diodes, its nonlinear behavior, VI characteristics. In particular, we talked about mainly ideal diode, forward biasing a diode, reverse biasing a diode. We also started with applications, and we saw that how we can use diodes to build rectifier circuits. We're gonna discuss more rectification later part of the chapter. We also saw that how we can connect the external supplies and resistors to limit the forward current. Today we are going to do one more application of the diode, how we can build logic gates using diode. We are going to do OR gate and AND gate, and then we will do a couple of examples on how we solve the diode circuits. Okay, so let's start with the lecture today. It's diode logic gates. So before I draw a circuit for a OR gate or an AND gate, let's define what is a low and a high in case of a diode, right? So usually 5 volt is high, around 0 volt is considered low. Right, so voltage values close to 0 volts are considered low. Voltage values close to 5 volts considered high. All right. So let's start with an OR gate. All right. So we have an OR gate. So here is a circuit of an OR gate. And this is V naught here. VA, VB, and VC. So you can consider all of these VA, VB, and VC as 3 inputs and 1 output, right? And we have connected a resistor to limit the currents. Now, if you remember, in case of an OR gate, if any of your inputs are high, then the output is high. The output is only low when all the inputs are low. We have 3 inputs here, VA, VB, and VC, which means that if any of this input is high, and high is close to 5 volts, if any of these input is high, this means that your output should be high. So we can see, right? So OR gate, if any of the inputs are high, the output is high. Now looking at the circuit, for example, if VA is 5 volt, VB is 5 volt, and VC is 5 volt, if VA, VB, VC, any of these are 5 volt, this means that their respective diodes will be forward biased and on, and will start conducting and will become on, and this means that our V naught will become high as well. Right, so it's a very simple gate where if any of the inputs VA, VB, or VC is high is around 5 volts, then this means that these diodes, A, B, and C diodes, will start to conduct. Whichever input is higher, that corresponding diode will conduct, and our output will be higher too. If all the diodes are high, output will be high. If any of the diodes is conducting, or if any of the inputs is high, output will be high as well. Okay. Now let's do a slightly more complicated gate, an AND gate. right? So AND gate is excuse me, our output is only high when both inputs are high, right? Our output is high when all inputs are high, otherwise output will be low. So let me make a circuit first. And okay, excuse me. Okay, so here's the circuit for an AND gate. Now let's look at how the AND gate is going to work. So first of all, we all know this table. If I have to write a table and then we're going to verify all the inputs, right? So I know that 1 0 0 0 0 1 0, over here the 1 is 5, 5 0 0 5 5 5. Right, so the output is only high when both the inputs are high, otherwise output will be low. All right, now so what will happen? The thing that happens over here is that our diode, when our VA or VB is low, meaning that 0 volts, since look at the polarity of our diode, this means that our respective diode will start to conduct, right? So at low, when VA or VB is low, then those diodes, respective diodes, will be conducting, right? So the same thing is happen when both VA and VB are low, both A and B conduct. So when these diodes are conducting, this means that A and B diodes, this will become a short circuit, and when that will become a short circuit, our output voltage will become equals to 0 volts. So in both of these conditions, our output voltage becomes 0 volts or low. Now what will happen when both VA and VB are high? When both VA and VB are high, now our diodes A and B will be off and open circuit. And when this diodes will become open circuit, this means that my V0 will become high or close to 5 volts. Of course, there's a resistor attached over here as well. So there's going to be a potential drop here, but approximately equals to 5 volts, and that will become high. So this is how we can make the AND gate as well here. Right, so we say that at 0 volts, when VA or VB are low, our diodes will start to conduct. And when these diodes are conducting, our potential drop V0 will become 0 because VA and VB are 0. And when so that is true when either of these, any of these diodes are conducting. However, what will happen is when both of these inputs, VA and VB, becomes high, then both of the diodes will become open circuit. And when both of the diodes will be off and open circuit, this means that my potential V0 will be equals to 5 volts, almost 5 volts or high. So this is how we can make an AND gate. So these are some very cool applications of diodes, rectifiers, and logic gates. We will discuss some more applications using more sophisticated rectifier circuits and how we can develop a power supply out of it. and more clipper and wave forming circuits, some of the applications that I discussed in the first lecture. We will discuss that towards the end of this lecture. We're gonna discuss more applications in detail. Now let's do a couple of examples on how we solve the diode circuits. All right, so we have here, let me go, example. Okay, so here's a diode circuit now. So there's a little sorry, this is connected to a voltage minus 10 volts, 5 kilo ohms, 10 kilo ohms, plus 10 volts. This is diode D2, plus minus V, and this is diode D1. Current flowing through this is I, and minus 10. All right, so this is a circuit that is given, and we are interested in finding I and V, right? So I'm interested in finding this value and this value. In order to make our life a little easier, I am going to, let's say, I'm gonna say this is my I naught, just to solve the circuit a little more easier, and I'm gonna say the current that is gonna flow through this branch will be ID2. All right, so whenever you are solving these circuits, the the way that we solve it, first we will make an assumption on the diodes. For example, we can make an assumption both the diodes are conducting or only one diode is conducting, one diode is off. Then the second thing that we do is verify the assumption, and third we do is change our assumption if needed, right? So we are going to solve it again and change our assumption if needed. So this is the iterative process that we are going to do. So first we are going to start with this. Okay, so solution. So let's start with an assumption. I'm going to assume D1 and D2 are both conducting. All right, so if D1 and D2 are both conducting, this means that my D1 here and D2 here are both conducting. Both of them will be short circuit. If both of them will be short circuit, let's also call this node as a node B. This will help. Right, then I can see that over here, if both of these diodes will be short circuit and conducting, then the potential drop at this node B will be 0 volts. Similarly, the voltage drop across D2, since it is conducting short circuit, so this capital V will also be equals to 0 volts. All right, so we ended up doing that. Now let's find the value of the current ID2. So ID2 will become equals to what is VB? VB was equals to 0 volts, so it will be 10 volts over 10 kilo ohms equals 1 milliamperes. So this will be the ID2 current. Now I'm going to write the current equation in node B. Current equation and node B. So the current equation and node B will be equals to, I have ID2 plus, so this current ID2 plus I will be equals to I naught, plus I equals to I naught. All right, I know the value of ID2. I want to determine the value of I don't know the value of I naught, so let's first find the value of I naught. So I naught will become equals to, what is I naught? I naught is flowing over here, so it will be 10 volts over 5k, 2 milliamperes. So the current I from this equation will become equals to I naught minus ID2. So I naught is 2 milliamperes and ID2 is 1 milliamperes. So answer will be 1 milliamperes. So my current I will be 1 milliamperes. So now I ended up finding both the values, V and I. So let's verify now. So let's verify our assumption. Now we can see that our current I is greater than 0. This means that my D1 is on and conducting and forward bias. Right? So in this case, so this means that since my D1 is conducting and forward bias, and that was my assumption too, that my both D1 and D2 are both conducting, and my V is 0 volts. So this means that my D2 is on as well. So this verifies our assumption, and our answers are capital V is 0 volts and capital I is 1 milliamperes. So our assumption was correct. And here are our answers. Now I'm going to do another example in which we are going to make an assumption and we are going to find out our assumption is incorrect, and then we are going to make another assumption and verify that one. All right, so let's do another example. The circuit is pretty similar with a slightly different values of the resistors. All right, so here is another example now. Circuit is actually similar. The values of the resistors are different. This is D1, D2. Sorry, this is 5K, and this is plus 10 volts. Right, and I have to find the current I here. I will do exactly the same thing. I'm going to call this node as B, this current as I naught, and the current flowing through over here as ID2. And we have to find V and I values. Okay, so everything is given. Now let's start the solution. Our solution is make an assumption. So let's again start with the same assumption that both D1, D2 are conducting. So if both D1 and D2 are conducting, this means that the VB voltage and the node voltage is 0 volts, and this V across the second diode, D2 diode, is also 0 volts because it is conducting short circuit. Potential drop across it will be 0 volts. So we are going to do exactly the same process. I am first going to find the diode, the current flowing through the diode 2, ID2, which is going to come out to be now 10 volts over 5K, 2 milliamperes. Okay, so ID2 is 2 milliamperes. Then I will write the equation at node B, the current equation at node B, which was ID2 plus I equals I naught. So let's find the value of I naught. I naught equals now, we have 10 volts and 10 kilo ohms. So 10 over 10 is 1 milliamperes. So capital I will become equals to now 1 minus 2 minus 1 milliamperes. Okay, so this gives us both of the answers now. That my V is 0 volts and my capital I is minus 1 milliamperes. Now let's look at this capital I. this capital I shows that my current, my assumption was that D1 is conducting, D1 is short circuit, and the diode only conducts in a unidirection. The current through the diode will never flow in the opposite direction. Assuming an ideal diode. All right, so in that case, because later we are also going to discuss the reverse current. However, for solving this circuit, assuming an ideal diode, the current in the forward, since we were saying that our diode is in the forward bias condition, in that condition the current is going to flow from anode to cathode. So this means that the direction of the current I as a negative -1 milliamperes is not possible. Right? So this is not possible. So assumption is incorrect. Okay, so let's make now next assumption. Okay, let's do the analysis again, make the assumption again. Now our assumption is D1 is off and D2 is on. All right, if D2 is on, this means that V is 0 and D1 is off. D1 is off means D1 is open circuit. So this D1 is open circuit, and if I am going to make D1 open circuit, then I am going to have this big long branch of the current. Then my ID2 is going to flow like this, right? All right, so now I'm going to find ID2. ID2 will be equals to 10 plus 10. That is going to come across both the supplies and both 5 plus 10 K resistors. 20 over 15K, the answer will be 1.33 milliamperes. And now since our D1 is off, this means that our I is also not flowing here. I is also 0. Sorry, excuse me. All right, so since our I is 0 now, because D1 is off, so our ID2 will be equals to I naught. All right, now let's write the voltage at node B. Voltage at node B. So the voltage at node B will be equals to at this node now. What is the voltage value at this node? We're gonna have 10 volts plus VB equals to 10K multiplied by 1.33 milliamperes. So here's an equation. Now we can see that sorry. All right, so at node B we can see that, right, we have a power supply 10 volts plus the voltage that is appearing over here, and the resistance 10K, this one, and the I naught 1.33 milliamperes. So by solving this equation, we can easily find the value of VB value. So VB will come out to be, what's the value of the VB? 3.3 volts. All right, so this means that now okay, now let's verify our assumption. Let's verify. What is the value of the VB? VB is 3.3 volts. So this means that the potential drop, right, so this VB here is 3.3 volts, right? So this means that I have a potential drop of 3.3 volts like this, and this potential drop means that the D1 is off and open circuit, right? So D1 is reverse biased. All right. So the potential, since our D2 is another thing is, since our D2 was short circuit, so actually it will not be 0 volts now. Since our D2 was short circuit, so the potential difference over here, this was 3.3 volts, so the potential difference, and D2 was on. Okay, so D2 is on and short circuit. Since D2 is short circuit, so the potential difference, this V in between this point and this point will be the same. And this is with respect to the ground, so our actual V will be equals to VB here, will be equals to 3.3 volts. So these are the values of current and the voltage now. So the value of the current will be equals to 0 milliamperes because our D1 diode is off, and our value of the voltage across the diode D2, which was conducting across that node, this point, and with respect to the ground, is equal to 3.3 volts. So this is how we can solve the circuit. Okay, so the take-home message in today's lecture is, the first one is the logic gates. We can easily build the logic gates using the diodes. Low usually means 0 volts, around 0 volts, and high usually means around 5 volts. We saw that at the OR gate, at this OR gate, that our, if any of these inputs are high, this means that respective diode will conduct and our output will be high. For the AND gate, we saw that in this circuit, if we're going to draw the circuit in this way, this is going to behave as an AND circuit, and we saw that if any of these inputs are low, if both inputs or any of the inputs are low, this means that that diode will start to conduct. Because of the, you can note that the polarity, the diode is connected in the opposite polarity now. And when this will happen, the output will be low. The only way it will be, output will be high, is when both the inputs are high. When both the inputs are high, because of the, again, the polarity of the diode, both the diodes becomes reverse biased in open circuit, so our output will become high. Then we saw that in order to solve any of these diode circuits, we first make an assumption, then we verify that assumption and change the assumption if needed. For example, in this case and in the next example, we first make an assumption whether both of the diodes are conducting or off, or one is conducting and the other is off, and then we solve the circuit, and then we see that whether that assumption holds or not. And if that assumption does not hold, then we change it, and this is what we have seen over here, that we have to change that assumption. All right, so with that, this ends our lecture. Okay, I will talk with you in the next lecture. All right, thank you so much. Bye-bye.